Hi everyone, I'm Andy and welcome back to the AI Breakdown. I thought it would be good timing for an episode on vibe coding, as it's been just over a year since Andrej Karpathy coined the phrase and gave a name to something a lot of people were starting to feel, where you essentially hand more of the building process over to the AI, you keep nudging it forward, you accept more than you probably should, and the code starts to feel a bit secondary to the momentum. At the time, it sounded half like a joke and half like a glimpse of the future. A year on, it's not a joke anymore. AI-assisted coding has moved from an interesting experiment to a serious operating question for software teams. Founders are talking about it. CTOs are trying to standardize around it. Developers are using it every day. And the claims coming from the industry are only getting bigger. But here's the question I want to focus on today. Has this actually made software teams faster, or has it just made them busier? That's really what this episode is about. I want to look at what adoption actually looks like, what the more credible research says about productivity, why junior developers may be at risk of getting squeezed out of the pipeline, and why I think a lot of teams are still confusing benchmark progress with real engineering progress. And finally, I want to lay out what I think the more useful path looks like from here, moving beyond hype, beyond recklessness, and towards a more disciplined model of AI-first engineering. Before we get into it, a quick word from our sponsor. This episode is sponsored by Notify Technology, a health and safety software partner helping teams run incident management, audits and inspections, and risk assessments in one place. And with Notify Spark, their AI companion, they're streamlining incident reporting and investigations, saving time, reducing admin, and helping teams act faster on what matters. You can learn more at notifytechnology.com. So let's start with the obvious point. AI coding tools are now mainstream. Stack Overflow's 2025 developer survey found that 84% of developers were using or planning to use AI tools in their development process, and among professional developers, just over half said they use them daily. GitHub Copilot has millions of paid users. Google and Microsoft have both talked publicly about meaningful percentages of code being generated by AI and then reviewed by engineers. That all sounds impressive, and some of it probably is, but I still think percent of code written by AI is mostly a vanity metric unless you connect it to things that actually matter, like defects, incidents, lead time, reliability, on-call pain, security issues, and customer impact. Executives love a number that sounds clean and inevitable. Engineering reality is rarely that neat. And that's why the second part of the story matters just as much as the first. Adoption is up, but trust is not. In that same Stack Overflow data, trust in AI-generated output is weak. Only a minority of developers said they really trust the accuracy of AI tools, and one of the top frustrations was that the output is often almost right, but not quite. I think that's one of the most expensive forms of wrong, because when something is completely broken, you throw it away. When it is nearly right, you keep working it. You tweak the prompt, you paste in the next error message, you ask for one more pass, then one more after that. And before long, you've spent 45 minutes supervising the machine to produce something you may have written more cleanly yourself. That, to me, is one of the defining feelings of this period. AI is clearly useful, but it also creates a lot of convincing near misses. And there's one other number worth keeping in mind here. On vibe coding specifically, most respondents said it was not part of their professional work. So yes, AI-assisted development is becoming normal, but the full Karpathy-style accept all and don't read the diffs approach is still nowhere near normal engineering practice. Which brings us to the part everyone really cares about, productivity. Has this actually made teams faster? The best independent study I've seen on this so far came from Meta, and what makes it interesting is that it wasn't a vendor case study. It was a randomized, controlled trial using experienced open-source developers working on real issues in their own repositories. These weren't toy tasks. They were real bugs, features, and refactors in large, mature code bases that the developers knew well. And the headline result was surprising. The developers were slower with AI. On average, the study found they took about 19% longer when using AI tools. What makes that even more interesting is that the developers themselves expected the tools to make them faster. And even after doing the work, many still felt faster, even when they weren't. So at the company level, they found no measurable improvement in delivery velocity or DORA metrics whatsoever. They call it the AI productivity paradox. Individual output goes up, but the bottleneck just shifts downstream to review, QA, and release. That gap between perception and reality is a big part of the story. Because I think a lot of teams are living inside that gap right now. The interaction feels productive, there's momentum, there's more output on screen, the model replies quickly, it gives you the sensation of acceleration. But when you zoom out and look at elapsed time, review effort, rework, and downstream issues, the gains are often much less clear. Now, to be fair, Meta doesn't prove AI makes everyone slower in every setting. The sample skewed toward experienced developers working in complex code bases they already knew well. That matters. AI may well help more on greenfield work, well-scoped tasks, or unfamiliar domains where drafting speed matters more than deep system knowledge. But I think the study lands an important blow against the lazy version of the story, which is, AI coding tools automatically make engineers faster. They don't. Not automatically. At the organizational level, the picture gets even murkier. Pharos AI looked at telemetry across a large number of teams and found their very own AI productivity paradox. Teams with high AI adoption appeared to complete more tasks and merge more pull requests, but review times went up, PR sizes grew, and bug rates also increased. In other words, output increased, but the bottleneck often just moved downstream. That makes sense to me. If AI helps engineers create change faster, but you haven't redesigned review, testing, QA, or release management, then all you've really done is increase the volume hitting the rest of the system, and once that happens, the gains start leaking away. So this is probably the key distinction I'd make if you're leading an engineering team. Code generation is not the same thing as software delivery. AI may speed up parts of coding. That does not mean it speeds up the full path from idea to reliable production outcome. And I think this is where a lot of the confusion around vibe coding comes from. Vibe coding in its original form is basically a surrender to momentum. Don't overthink it, don't stare at the code too hard, keep pushing, keep prompting, keep going. That can absolutely work for prototypes, throwaway experiments, internal tools, and maybe some very lightweight products where speed matters more than elegance and the cost of failure is low. But that is not the same thing as professional software engineering inside a serious product company. That means using AI to draft, explore, refactor, test, and accelerate, while still keeping human judgment around architecture, security, trade-offs, and the final decision to ship. It means using agents, but with guardrails. It means tighter specs, better context, stronger tests, and clearer checkpoints. So for me, the useful distinction is this. Vibe coding is one extreme. AI-first engineering is something else entirely. And the benchmark story matters here too. If you've followed this space, you've probably seen endless charts showing models getting dramatically better on coding benchmarks like SweBench. On paper, that makes it look as though autonomous software engineering is nearly solved. I don't think that conclusion survives contact with reality. In fact, OpenAI has now said, as of last month, it has stopped reporting SweBench verified scores altogether because it no longer sees the benchmark as a reliable measure of frontier coding ability. Their analysis found two big problems. First, a lot of the remaining tasks are flawed tests that can reject functionally correct solutions. And second, the benchmark has become contaminated, with models showing signs they've effectively seen parts of the problems or solutions before. So the score starts to reflect benchmark exposure as much as real engineering capability. And that matters because once a benchmark becomes widely known, widely discussed, and heavily optimized against, you can get a kind of benchmark theater. Not necessarily outright cheating, but a system where the field learns the test. One recent analysis of SweBench found that more than 60% of successfully resolved issues involved some form of solution leakage, and nearly 48% were cases where weak tests made a patch look correct when it wasn't really robust. When those issues were filtered out, average resolution rates on SweBench Verified dropped from 51.7% to 25.9%. That's also why more rigorous evaluations matter. When Scale AI introduced SweBench Pro, designed to be harder and more realistic, performance dropped sharply versus verified, and their private held-out subset was harder again. For me, that's the useful takeaway. Yes, the models are getting better, clearly better, but benchmark improvement and production readiness are not interchangeable. Real software work is messy. Requirements are incomplete. Constraints are implicit. Architecture matters. Backwards compatibility matters. Maintainability matters. Security matters. Operability matters. Passing a benchmark is not the same thing as producing a change you actually want to own for the next 2 years. And I think that becomes even more obvious when you look at what this means for people, not just output. One of the most important pieces written on this, called Redefining the Software Engineering Profession for AI, and published last month, came from Mark Russinovich, Azure CTO and Deputy CISO, and Scott Hanselman, VP of Developer Community. Their argument, put simply, is that AI may be giving senior engineers a real boost while creating drag for early career developers. And that rings true to me. If you already have strong judgment, deep context, and a good feel for system trade-offs, AI can act like leverage. You know what to ask for, what to ignore, and when the output is subtly wrong. If you don't have that judgment yet, the same tool can be much more dangerous. Because early career developers are still learning how systems behave. They're learning how to debug, how to reason about failure, how to spot when a fix is plausible but poor, and how to build taste. If too much of that early work gets replaced by AI-generated output that they supervise only loosely, then the learning loop changes. And we're starting to see signs of that in the data. A Stanford working paper using ADP payroll records found that early career workers aged 22 to 25 in the most AI-exposed occupations saw a 16% relative employment decline, while employment for more experienced workers stayed broadly stable. At the same time, LeadDev's 2025 AI Impact Report found that 54% of respondents expected less junior developer hiring in the long term. So if companies respond by hiring fewer juniors because senior engineers look more productive with co-pilots, then you get a deeper problem. You improve short-term throughput at the cost of the future talent pipeline. Senior engineers do not appear out of thin air. They are grown. They are shaped by messy work, repeated failures, code reviews, debugging sessions, and years of being slightly out of their depth until they are not. So if you're hiring fewer junior developers in an AI-heavy environment, I think you owe the organization a serious answer to one question. How are juniors supposed to become seniors here? That is not a side issue. That is a strategic issue. And there's a related risk sitting right beside it, which is quality. One of my concerns with this whole shift is that teams can start to feel faster while quietly making the system worse. More duplicated code, more shallow fixes, more code that passes the immediate bar but adds maintenance cost later. More security issues introduced by speed and overconfidence. And there are some early signals of that. GitClear's 2025 analysis of 211 million changed lines of code found cloned, copy-pasted code rising from 8.3% of changed lines in 2020 to 12.3% in 2024, while refactoring-related moved code fell from 25% in 2021 to under 10% in 2024. That is exactly the kind of pattern you'd expect if teams are shipping more code, but doing less of the cleanup and consolidation that keeps systems healthy over time. And on security, the picture isn't especially comforting either. Vericode's 2025 GenAI Code Security Report found that AI-generated code introduced risky security flaws in 45% of tests, and that larger, newer models did not reliably produce more secure code. Earlier research from Stanford also found that developers using an AI assistant wrote less secure code and were more likely to believe their code was secure, which is a pretty uncomfortable combination. In other words, AI can become a very effective way of taking on technical debt without fully noticing you're doing it. Like a credit card, you get the benefit up front, but you pay for it next quarter. That doesn't mean the tools are bad, it means the governance matters. And that brings me to cost, which I think is still under-discussed. A year ago, the story was basically, pay a monthly subscription, 20 quid a month, and everyone gets smarter. Now the picture is much messier. GitHub Copilot Business is $19 per user per month, and Enterprise is $39, but GitHub also now charges 4 cents per additional premium request once you go beyond plan allowances. Cursor has moved even more obviously in this direction. Its $20 Pro plan now includes $20 of agent usage, Pro Plus is $60 with $70 included, and Ultra is $200 with $400 included. So the second you move from one assistant per developer to heavier agentic workflows, cost stops behaving like a simple SaaS license and starts behaving more like variable cloud spend. So this stops being just a tooling decision and becomes an operating model decision. You need budgets, you need visibility, you need to decide what work is worth spending tokens on and what isn't. Otherwise, finance tightens the screws, developers work around policy with personal accounts, and nobody is really managing the system properly. And the awkward part is that a lot of companies still are not managing it properly. Lead Dev reported that only 18% of organizations are even measuring the impact of AI coding tools at all. So, in many teams, spend is getting more complex before governance has caught up. Which brings me to where I've landed 1 year on from vibe coding becoming a thing. I don't think the honest takeaway is that AI coding tools are overhyped and useless. They're not. They're already genuinely useful in a lot of contexts, but I also don't think the honest takeaway is that software development has been solved, or that production engineering is now just a matter of prompting harder. For me, vibe coding in its truest sense is still immature. It is interesting, it is useful. It is clearly opening the door to faster prototyping and a much lower barrier to creating software. And platforms like Lovable have shown why that is exciting. But for serious, long-lived production systems, I don't think vibe coding is the model, not today. The quality bar, the reliability bar, the security bar, and the maintainability bar are all too high for a loose approach to be enough. That's not a criticism of the tools. It's just a recognition of what production software actually demands. And this is where I think it helps to make a distinction between AI-assisted engineering and AI-first engineering. AI-assisted engineering is what most teams already recognize. Using tools to help write code, explain a code base, answer questions, suggest tests, draft pull requests, or speed up individual tasks inside a basically familiar development process. Useful, absolutely, but still mostly an assistive layer on top of how teams already work. GitHub's own description of emerging AI-assisted workflows fits that world quite well. AI-first engineering is different. That is where you start with the assumption that agentic systems are now part of the delivery model, and you redesign the process around that reality. Briefing becomes more important. Context becomes more important. Structured agentic workflows become more important. Reviews happen differently. User stories, plans, code changes, tests, and pull requests all need clearer checkpoints. And human-in-the-loop approval is not some annoying extra layer. It is part of how you get the value safely. In other words, the win is not just use more AI. The win is building a system that gets the best out of AI without pretending the first answer is the final answer. That is much closer to what Carpathy has recently described as moving beyond vibe coding towards something more like agentic engineering. That is the approach I find much more convincing, and it is the one I'm leaning into myself. Not replacing engineering with prompting, but rethinking engineering so AI is built into the flow from concept through to delivery with stronger orchestration, stronger checks, and much more deliberate use of human judgment. What this does not solve, though, is the people problem. It does not solve the challenge of bringing through the next generation of developers and helping them become seniors. And it also does not fully solve the identity shift for today's developers, because some of the work is moving away from hands-on implementation and towards orchestration, supervision, review, and systems thinking. That is a real shift. Some people will thrive in it, some will hate it. But either way, I think we need to be honest that the role is changing and heading this way. So if I were leaving engineering leaders with one challenge, it would be this. Don't just ask how to plug AI into your current process. Ask what your process needs to become if AI is going to be a real advantage. And at the same time, start asking a harder forward-looking question. What will a strong, senior software developer look like 2 or 3 years from now? Because if that profile is changing, then your hiring, mentoring, and development pipeline need to change with it. That, to me, is the real work now. Not deciding whether AI matters, it clearly does. The real work is redesigning how we build software, how we govern quality, and how we grow people in a world where AI is now part of the engineering system. Thanks for listening, and I'll catch you next time.